Okay, so I'm going to use the pH pen, which is connected to the iPad, and I'm going to measure the pH of several different solutions that are salt. So the first one is ammonium acetate. So the ammonium ion comes from a weak base, ammonia, and the acetate comes from a weak acid. So it's the salt of a weak base and a weak acid. Remember, a salt is what's formed when an acid reacts with a base. It comes in at 8.05. Okay, the next solution is ammonium chloride. So this is from ammonia. It's the salt of a weak base and a strong acid. The chloride comes from hydrochloric acid. pH is 6.76, so it's slightly acidic. Our next salt is sodium chloride. It's the salt of a strong base and a strong acid, sodium hydroxide and hydrochloric acid. That's our third. So what do you think the pH should be? Should sodium chloride react with water? Comes in right at 6.98. Our fourth is sodium acetate. Again, sodium from a strong base and acetate from a weak acid. So the sodium is not going to react with the water. The acetate is going to react with the water to take away a hydrogen from the water, leaving hydroxide behind. 7.51 for sodium acetate. Our next solution is going to be sodium monohydrogen sulfate or sodium bisulfate. So the bisulfate comes from the sulfuric acid, and the sodium comes from sodium hydroxide. pH of 1.74. Quite acidic. So you can see salts are not necessarily neutral, even though they're from the reaction of an acid and a base. Our next salt is going to be iron 3 chloride. So iron is a transition metal with a +3 charge, and then the chloride comes from the strong acid hydrochloric acid. You might be surprised to see that the pH is 1.33. It's quite acidic. Next we have sodium dihydrogen phosphate. Dihydrogen phosphate comes from phosphoric acid, which is a triprotic acid, and of course the sodium from the sodium hydroxide. pH 4.38. Next we have sodium monohydrogen phosphate. So this is similar to what we just did. However, we've removed one of the hydrogens and stuck on another sodium. Whereas the dihydrogen phosphate was acidic, the monohydrogen phosphate is basic, 8.43. The last salt we're going to measure is sodium bicarbonate. Again, these are all 0.1 molar solutions, pH 9.04. While we're at it, let's measure the pH of deionized water. Let's see if it actually comes in at 7. This deionized water is actually quite high. It has a pH of 9.3. So I can tell our other solutions were not made with this batch of deionized water. It's also very hard for these pH pens to measure the pH of deionized water because there's no ions in it. Now what I would like to do is in each of the solutions, I'm going to place some universal indicator, and you can record the color. So in our first solution, ammonium acetate, you can record the color. Second, ammonium chloride, This just gives us a visual, the different pHs. This is sodium chloride. This is sodium acetate. Next we have sodium bisulfate. Ferric chloride. Now the yellow is going to mask things, but you can see it's still red, acidic. Sodium dihydrogen phosphate. And sodium monohydrogen phosphate. So changing one hydrogen makes a big difference. Let's do sodium bicarbonate, found in baking soda. You can see that's fairly blue. And then lastly, our deionized water. It still turns out to be close to neutral. Remember, the pH pen has a difficult time measuring something with no ions in it. It's designed to measure ions. So now you can collect your data and complete the rest of the lab report.